second pillar of Lean is value stream. Identify all the steps in the value stream, eliminating each step that does not create value. I believe that there is no specific agile practice that really helps here, though all of XP's practices implement the simplicity value, which consists in maximizing the amount of work to not do. So we practice classical Lean value stream mapping, and you have a value stream map of our current project. However, when you practice value stream mapping, you have to learn to identify waste. Waste is work that brings no value. For example, in our industry, we are terrorized by the fact that our software could not fit on the target due to CPU load and excessive memory occupation. Therefore, many in our industry optimize their code prematurely. And in fact, they optimize on fear and not on facts. So I'll try to show you that premature optimization is waste. Well, simply because maybe the code is good enough. And then the effort you spend on optimizing is completely lost. And even worse, the code is more complex for no reason. Therefore, our practice is to not optimize prematurely. However, to do this, you have to monitor performance early and often. Then you can optimize specifically on hard facts. Indeed, we think that it's much easier to make a correct program fast than it is to make a fast program correct. Okay? So to get these hard facts, we automate CPU load and code profiling early in our development process. The third value is flow. Make the remaining value creating steps occur in a tight and integrated sequence so the product will flow smoothly towards the customer. So to create a steady flow of finished work, we reduced the size of the batches of work. We adopted Scrum's time box called a sprint. A sprint is a monthly iteration which produces an increment of potentially shippable product. And iterative and incremental development in short cycles create a continuous flow of finished work. And to maintain this flow, we have to fix the problems that slow down the flow. For example, desynchronization slows down the flow. As soon as a worker changes something in his own private workspace, he is desynchronized from the mainstream code. And there will be some amount of work to push his changes into the mainstream product. This effort is generally called integration. We minimize desynchronization and integration thanks to two agile methods. First, we practice Scrum's daily stand-up meetings. They are short, daily, time-boxed, and focus meetings, focus team meetings. They're time-boxed to 10-minute tops. And each team member has to answer the three questions. What has he done yesterday? What does he plan to do today? And what slows down his work? Daily stand-up meetings synchronize the team workers and their activities. And of course, we practice continuous integration. Continuous integration creates a steady flow of tested, integrated, and shippable code. So thanks to these two practices, we synchronize teamwork and the product so they are desynchronized as short as possible. After desynchronization, bugs slow down the flow as time is spent on debugging. So, to maintain a steady flow, we try to prevent bugs from creeping into the software. We have adopted a preventive attitude towards bugs. For example, we practice test-driven development. In test-driven development, the tests are meant to prevent bugs, not to detect them. Okay? You write the test before you write the code. And you write the code to make the test pass. Okay? You prevent bugs. You do not detect them. We also practice safe deliver. In our development environment, a developer cannot deliver his code if the test failed. To prevent bugs, we practice pair programming. The code is systematically reviewed before it is delivered in the project repository. And we practice design by contract. So, design by contract prevents bugs as it leads to foolproof code. Indeed, you cannot use the code in any other way than specified by its preconditions. I don't know if you're familiar with design by contract. Maybe I should just say something on it. Design by contract is a technique that focuses on documenting, checking, and agreeing to the rights and the responsibilities of software routines to ensure code corrections. The rights of a routine are its preconditions. The responsibilities of a routine are its postconditions. Okay? And these preconditions and postconditions can be checked at runtime in your software by using assertions. And if ever at runtime a precondition or a postcondition fails, the assertion fails, and the program and the software aborts. So, by writing full proof code, you prevent bugs. Unfortunately, bugs still manage to creep into the software. So, to maintain a steady flow, we practice Lean's stop the line. Stop the line consists in organizing your work so you can automatically detect defects, and then you stop your work and you correct the problem. For example, our continuous integration system builds our product and tests it as soon as it detects a change in the mainstream code. And then it yells by sending an email to each developer as soon as it detects a failure. And then our main priority is to stop our work and correct the bug. The automated build, the automated tests, and the design by contract assertions in the code exercised by the test act as the failure detectors. Design by contract also helps to implement stop the line, because when a precondition or postcondition assertion fails, it aborts the code, and if you want to run it again, you have to fix the bug. You can't run it again. So these two practices, continuous integration and design by contract, create a true culture of stopping to fix problems in order to get quality right as soon as possible. We also create a continuous flow of information inside our team by co-locating the team in a common workspace. And we use visual control so no problems are hidden. Our workspace is loaded with information such as Kanban charts, which identify bottlenecks, with burn down charts, which reveal progress, and with blocking boards, which show the impediments. So, iterative and incremental development in short cycles with continuous integration is a short cycle process that creates a constant flow of finished work. And this constant flow brings problems to the surface. And then, to maintain the flow, you have to stop and fix the problems. The fourth principle of Lean is pull. As flow is introduced, let customers pull value. So, the features to implement are prioritized by the product owner in the product backlog. And the succession of iterations will pull the highest priority features out of the backlog and transform them into valuable software. So, by prioritizing the features, the customer is in fact pulling the development of his product. Just to finish, this is really important. Iterative and incremental development of prioritized features is just the pull system for product development.